Electronic configuration, which we discussed in previous class, and what is the capacity of number of electron for S is 2, P is 6, D is 10, F is 14 respectively. Then we had seen so many example with the writing electronic configuration, and now we are moving from the silicon having 14 number of electron, and its respected electronic configuration is 1s2, 2s2, 2p6, 3s2, and this is 4p2 electronic configuration. That's way we have to increase, or now you may cross verify the electronic configuration 2 to 4, 6, 10 to 12 to 14. 14 is its atomic number. That's way you will increase your atomic number and decorate the electronic configuration what with its capacity to filling the electrons. According to this you can fill the electron. Now our term for the next element is phosphorus having 15, and you can write like 1s2, 2s2, 2p6 and 3s2, 4p3. Like this you can fill up to 6 electrons. So phosphorus then we are just it is no more modification is required in this, but we are discussing on the exceptional portion of position. So up to like this phosphorus then you may write the electronic configuration for sulfur. Then you can write sulfur having 16, you will try by yourself. And then you go for chlorine having 17 number of electrons. Then next is we have right for the argon, which having 18 number of electrons. You can try, because there is no any, simply you will introduce the number of suborbit and specify the number of electrons with the its lower or higher energy in order, right? So, and then we have argon. Later it comes with the potassium and calcium have 20 and potassium have 19. There is no any exception is colliding up to here, right? If you are looking for the other element, then it is stand for scandium. Just we are giving you a little idea because you don't be confused. Scandium we are showing because this is a transition element, and there is one more 3D element. 3D series will reach to us. That's why we are going to be writing the number of electron, in which what you will do 1s2, 2s2, 2p6, 3s2 and then 3s2. Next is 3p6, 4s2 and 3d1. Like this. Now you can fill the electron 2, 2, 4, 6, 10, 12, 6, 18 and 3, 21. 21 electron we are decorated. Scandium having 21 electronic configuration. So you know capacity of electron enrolling in D is up to 10 electrons. You can substitute up to 10 electrons in this, right? And in this situation what you are finding, you can D having capacity for 1 to 10. So next element without resistance, just you write the electronic configuration. So scandium, then you may write for the titanium, and then you write for the vanadium. This is 22, this is 23, and next element is chromium, which is exceptional or stressed area, where we have to be more focused, because this is not this is for the normal rule is not followed. In chemistry we are getting exception on chromium, which having atomic number is 24. So keep more stress when we are writing electronic configuration of chromium. There one scientist statement is also supported this idea to filling the electrons. That scientist name is Aufbau principle. Aufbau principle is stating that if any one element have half filled or full filled orbital, then it is highly stable in nature. Like simply you will say, if some element have capacity of 10 electron, right, and it is going towards the 5 electron, it means this is half filled position, it is full filled position. Both the situation we having highly stable in nature. High stability. Memorize this better. If there is ability electrons, number of electron is either half or either fulfill, both having highly stable in nature. Similar, we are going for the p having capacity for 6 electron, it is filled, but when it is p having 3, it means this is also half filled. So memorize this. In this situation where capacity of electron and its half number of electron is filled, it means that is following with the high stability in order. So in our chemistry, we are finding two places our exception. One is stand for chromium, another stand for copper, which we have discussed it now. So just you are keeping more operational ideas with the chromium. We are discussing now on chromium. So in this chromium case, we can write the electronic configuration. First of all, we are writing general electronic configuration, by which it's easy to analyze and understand the things clearly. Chromium having 24 its atomic number. So you can write 1s2, 2s2, 2p6, 3s2, 3p6 and 3d, 4 and last is beta 4s2. See, now you count the electrons. How many this is? This is for 2, 2, 4, 6, 10, 2, 12, 6, 18, 4, 22 and 2, 24. 24 electron you decorated. But in present scenario, what you are watching, D having 4 electron, while its capacity for 10 electron. Half of 10 become 5. So there is little exceptional area that will provide the electron towards D. That electron going to be migrate, going to be excite from here and enter towards the D, because it making stable in order to suborbital, right? So in this situation, what this element do? This is normal what we are thinking, and what is our normal rule, that is a statement like this. But exceptional is saying, according to our scientist ideas, 1s2, 2s2, 2p6, 3s2, 3p6 and it become beta 3d5 now, 3d5 and 4s1. What is happen here? One electron going to be entered in penultimate cell where only 4 electrons. After gaining 1 electron, it become d5, which is highly stable in nature. We already discussed in paper, if any element have half filled conditionality, they are half filled nature, they are highly stable. So see, if d10 it is stable and d5 it is stable, p6 and p3 both are highly stable in nature. That's why we are just changes our idea to fill the electrons by the normal state to excited state, right? So according to this, we have to do like the finalizing the electronic configuration. Clear? Now you may write electronic configuration for then next is all about elements. What is same? You have to follow the rule. Next element is manganese, iron, cobalt. You can write for manganese, iron, cobalt have this idea 25 for manganese, 26 for iron and 27 for cobalt. And next element is you have to do nickel, which having 28 electrons, right? Next is copper, which is again our exceptional area better. Otherwise you have to follow a common rule, normal rule. There is no any exception took place. But in case of chromium and copper, up to 30 atomic number we are discussing here. In our syllabus also we have to write up to 30 electronic configuration. So copper is our second last element. How we are writing for copper? So in general rule, we are writing for copper electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and again we can write this is 3d9 and 4s2. 3d9 and 4s2. Again, what you are analyzing, these having same situation. Previously it was half filled, now it comes with the full filled. It means if you remove electron from the outer and insert the electron at penultimate cell, it becomes d10 after gaining one electrons from the outer side, and it become highly stable in nature according to our scientist, right? So what we will do, it is normal condition of electronic configuration what we substituted now, but where we are proceeding for actual, what is the actual electronic configuration? 1s2, 2s2, 2p6. Don't be ignored, this is a very important question in our syllabus, right? So please be careful what we are doing here. 3p6, because a small mistake give you award with the zero answer, 0 marks, right? So one electron going to be saved, it become 3d10, it become beta 3d10 and 4s1. One electron going to be migrate. Why it going to be migrate? Because it want to be making a stable in order to any elemental electronic configuration, that's why it is going to be migrate. And we know half filled and full filled orbital are highly stable in nature. So there is electron migration took place, and this is our actual electronic configuration for, this is our expected, previous one is expected, but actual electronic configuration is this. So you have to write in examination, they want to be like a descriptive answer or long range answer. You have to write a normal electronic configuration as well as expected electronic configuration. In previous situation for the chromium we had also changes like same scene, where we are finding d4 is approaching the half filled orbital configuration by providing one electron from its outermost subcell, and by which it converted to d5, which is highly stable. So previous one was the normal situation, or this is final situation, this is expected, this is actual, right? So memorize, this is exceptional area. And then we have to follow the simple rule for the zinc. You do not have to any changes, simply you will write the electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6 and 3d10, 4s2. Now you may cross verify is all electrons are subdivided perfectly or not. So 2, 2, 4, 6, 10, 2, 12, 6, 18, 18, 10, 28 and 2, 30. So 30 electron is already inside the electronic configuration, and 30 is its atomic number. So perfectly it is correct. According to that, our topic electronic configuration is closed. But I am requesting to everyone, do lots of practice, write too many times, because this is decide too many physical and chemical characteristic of compound. It is highly correlated inside chemistry. Everywhere you have to be focused whatever we discussed in electronic configuration. This is very important topic. Please, I am requesting once again, you will try by yourself without watching what we had done, and do up to 30 electronic configuration. We escape some because it is just a consumption of time, that's why we had just missed these elements, but I was providing you data. Manganese have atomic number 25, iron have 26, cobalt have 27, nickel have 28, and some element also we had provided to you where we wrote the number of atomic number, like titanium have 21 and vanadium have 23. These whatever the element I was left, please write the electronic configuration. If you find any problem you are unable to solve, write the message. I will project your whatever the queries regarding the electronic configuration. Thank you.